新房包含东海大学。
I'm Fujian from National Young Children University in Private campus. Okay, then our team to briefly introduce yourself. First, from the reporter.
Hello everyone, we are Team Volcom. I'm the captain Zhong Yixing and they are my teammates. Silu, Jiajing, Li Zhen. Thank you.
And maybe your common team.
Hello everyone, we are team Mingdao Mei En, and I'm the captain Roger, and this is YC, and this is Michael, and this is Alan, and this is Shou.
Thank you.
Hello everyone, I'm Captain from Mingdao, and this is Wang Di, this is Yopsi, this is Sai, this is Yu. Thank you very much.
Thank you very much. Okay, so let's start the procedure. So first, the opponent please propose a problem for the reporter. You have 1 minute.
We want to challenge problem 13 spaghetti accelerator.
Problem 13.
We accept.
Okay, good. So it's problem 13. Spaghetti something. Spaghetti accelerator. Jia-Jing, please start your presentation.
Hello everyone, I'm Jia-Jing from Team Photon. Today I'm going to report the problem 13, spaghetti accelerator. Here is the problem statement, where a piece of spaghetti is pushed into a bent tube. Small debris of spaghetti may be ejected from the other end of the tube at a surprisingly high speed. Investigate this phenomena. And our main focus, the first point, is the reason for the rapid ejection of the spaghetti. And the second point is analyze the factor affecting the speed. So here is the outline. First, we can say about experiment cell and theory and experiment. Here is the experiment setup. We use the force sensor to make sure we use the same force. And use the 3D printer to push the spaghetti to make sure the velocity can control velocity and can change the velocity. And we use the 3D printer too to change the curvature and the diameter. So we can define the radius of the curvature. We call R is the radius of curvature. And here is a measurement of a younger module. We fix the two sides and use the force in middle and to see the spaghetti elongate. So see the side view, the spaghetti didn't contain the bottom, so we use the 2D. Here is theory. In the first, we can talk about the reason why spaghetti break. The spaghetti will contain the tube at the 3 points. And the 3 points have the normal force and friction. So the outside have the tension and the inside have a compression. And the spaghetti break in the straight more part. But why didn't here break? It's because the right side have the two limits. So break is in the middle and the maximum stress. And here is energy transformation. Because the work done by the machine changed into an energy store in the spaghetti. We can see that the energy this is electric potential energy. And electric potential energy can change to a kinetic energy. But not all of elastic potential energy will change to a kinetic energy. So we can see this formula is the initial transfer coefficient. About the energy transfer coefficient, we can see this chart. The spaghetti in the beginning is not forward, so the spaghetti need to hit the tube and change the direction. And see here, this have the three force point. The N3 and N1 is not change the spaghetti direction because the normal force is vertical the spaghetti, and because in the corner the N2 the spaghetti the no force is not vertical the spaghetti, so spaghetti direction can change. And so see here, can see the N2 will change the spaghetti direction, and when the spaghetti break, the spaghetti will hit the tube again, so have another no force to change the spaghetti direction. But only the no force at the corner change the direction of the spaghetti, because if the tube is not bent, the normal force can vertical the spaghetti. And here is bend theory applied to spaghetti bend. Because the spaghetti deflection can change, but we calculate the deflection to prove about the about the applied force. Use of applied force to see the spaghetti transformation coefficient. So here is experiment. The first variable is curvature, about the way of ejection, applied force, and the ejecting velocity. Here is way of ejection. We can see the tail track. Can see when the curvature increase, the ejection length and the mass will decrease. And because when the bend more, the spaghetti push a little can reach the critical strength, so spaghetti will break. So when the curvature increase, the length and mass will decrease. And here is curvature about the force. Because we calculate the force, we know about the curvature increase, the length will decrease. Because when the curvature increase, the noodles into more flow to change the direction, so the applied force will increase. And so more elastic potential energy is converted into a kinetic energy. So we can see this chart. The first we can see when the curvature increase, the elastic potential energy will decrease, but because the mass also decrease, so this can same. But because when the curvature increase, the applied force will increase, so we can get the velocity will increase. And angular velocity is set, so it's not very affected. And the next variable is outlet diameter. Here is way of ejection. We also will see when the outlet diameter increase, the mass and length will increase. And because when the diameter increase, the spaghetti have the more space to forward, and the spaghetti enter at the longer angle, so curvature will decrease. So we can know about the outlet diameter increase, the ejected length and the mass of spaghetti will increase. So here is a force. We also can know about the outlet diameter increase, the length will increase, and we to calculate the applied force, the applied force will decrease. So less elastic potential energy is converted into a kinetic energy. And here is ejecting velocity. We can see the angular velocity is set in a different outlet diameter. And we can know this chart, we can get the outlet diameter increase, the ejection velocity will decrease. And so we know when the outlet diameter increase, the elastic potential energy increase, the mass will increase. But because the applied force decrease, so more elastic energy changes to the kinetic energy, so the velocity will increase. And here is about the inserting velocity, about applied force and the ejecting velocity. So this is inserting velocity about force. We can know when the insert velocity increase, the applied force and the length is the same. So we can know about because the velocity not only change the curvature and the diameter, so the applied force and length is same. And so we can know about the angular velocity also is same, but the ejection velocity will increase. It's because the insert velocity increase, so the initial kinetic energy increase, so finally kinetic energy will increase. So here is a conclusion. We use the model is fix the two sides and have a normal force in the middle, have a plus force in the middle, and we see a spaghetti. When spaghetti outside will have a tension and inside have a compression. And spaghetti will have the free contact point. And in theory, we can see a diffraction will change, but we also find the diffraction change when the curvature increase, the diffraction will increase. And we use this formula about the elastic potential and the transfer coefficient and the kinetic energy and the rotation energy. And because the rotation energy is very set in the experiment, so it didn't affect more. So we'll have three variables. The first is the curvature. When the curvature increases, the efficiency then will decrease, and the elastic potential energy will decrease, and the force increase, so the velocity will increase. And when the outlet increase, the efficiency then will increase, the force will decrease, so the velocity will decrease. Thank you for your attention.
On the bottom, you can have the same question.
Okay, so back to the where you have your curvature, but maybe the completion part. Yeah, so can I ask about, since you didn't specify, what is the meaning of P on this? The P? Yeah.
P is this is a plus force, is this point force.
Oh, okay, right. And what about the I down below here?
I is about the spaghetti about the
I'm sorry, is it a constant? Is it a constant?
yeah, it's
Okay.
about diameter. Spaghetti's diameter is about spaghetti diameter.
Okay, so say
You say I is this?
no, sorry.
This is spaghetti net. Then
Sorry, no, when we go. So do you consider any drag force in your kinetic calculation? Because I only see you have only discussed your location energy and your kinetic energy. Do you consider there should be any drag force?
can you say what
Do you think there will be a drag force applying to your spaghetti when the spaghetti is visiting the tube?
No,
Okay, alright. And
but we have considered about fission.
okay, alright. And in your video you demonstrated, do you consider before the spaghetti breaks and when there's a little phase before it totally go outside the tube, do you consider there will be some collision in between when maybe the video like you show when the spaghetti is exiting the tube? Do you think there will be collision on the surface
The
of the tube?
first sentence is said about so we only make sure the shear velocity.
Yeah, I mean during from here and to existence, do you consider there will be any kind of collision to the surface? Does it bump on this, bump on there?
Yeah, this can have the normal force, but no force is vertical, so it didn't affect, and the friction we have said about.
Okay, alright. Thank you.
Thank you.
So hi, this is an opponent from Middle High School. So they didn't have here opposing common learning spaghetti accelerators. So this is the focus statement. So their main focuses are the reason for the rapid ejection and relevant parameters. And this is the overview of their work. So they have 3 contact points with the tube and breaks due to the compression. And the work is done by the machine just warmed into energy stored in spaghetti, and the beam theory is applied into explaining the bending. And in the experiment, they do the applied force, they navigate the relationship between applied force and only the diameter and ejection length and mass the length to curvature and the ejection velocity to curvature. And these are their parameters. And their conclusion is that they have the analysis of the bending process and the curvature, the relationship between curvature and the ejected length, and they say it is positively correlated, and the only diameter and the ejected length, and they also stated it is positively correlated. And these are some of the pros and cons. You have clear observation and clear, they have abundance variables, but I think their theories are a bit unpersuasive because they have some fact manufacturer didn't consider and move on. So here are some point I want to discuss later. So I want to know if there's any rotation of the spaghetti, and I want to know more about the contact point and whether it has any collision before it is sent to the tube. And I want to know more about the acoustic I that you mentioned earlier because you didn't make it clear what is the definition of I. And I want to know if there is any environmental drag force considered in your theory. And about the experiments, I wanted to talk about the uniformity of the spaghetti because I see that in your every ejection, the length of the spaghetti is slightly different. So I think that could pose some changes to your calculation of deflection. And I also want to talk about the possible distribution location of your spaghetti because that might do something to the final collision of your spaghetti. And also I want to talk about the measurement of the deflection because you didn't make it clear, you didn't state it in your presentation. And I want to know the collision. Is there any kind of collision before the spaghetti exits the tube? Okay, so let's move on to the discussion first. So I want to talk about, do you consider there's any kind of rotation, like the rotation of spaghetti? How do you calculate this rotation?
Yes, we consider rotation in the angular velocity.
Yeah, so is it a constant under every condition, like when you change the diameter of the tube?
Yes.
Is the angular velocity constant?
Yes, consider in the
I
any.
mean, is it all the same? Like,
Yes, the very same.
okay, yeah. So I think there will be a slight change when you apply different force and different diameter. The angular velocity will be different. Okay, so and can you talk about? Can you show the video that you experienced when you just push it? Can you maybe? Yeah, this one. So before the spaghetti gets out of the tube, you consider in this area here, in this part, you consider there could be any collision.
Area?
Yeah, in this.
Because
this
here
space.
have this, but in this orange pond, because it's not a tube wall. The tube wall in here is not here.
Yeah, I mean this the spaghetti when it breaks, does it go directly out, or does it goes like this and out?
No, it can this a little.
Oh, so do you consider there might be some
I
energy
see,
loss?
maybe can, but I also show the trend about velocity.
So you don't have a exact calculation of that? Like how
I
does
see
the
that
collision
it
impact?
can.
Yeah, I mean, do you have a specific explanation on how collision affects your speed or your applying force?
When the spaghetti hits the tube, the velocity will decrease. But I also show the velocity trend in my experiment data.
Alright, so maybe can we talk about the I here?
I is a coefficient and it's about the spaghetti diameter. It's about
So how do you exactly, do you have any question to get the exact value of I? Like, have you any question or real number of it? Like, what's the value of exact value?
no the value, but in our experiment the I is same because we use the same spaghetti.
Alright, but okay, so in some of your experiments, you stated that the length of the ejecting spaghetti will be slightly different, and so I think there is a question of the differential of I to calculate it, and so I think the difference in the length of it will cause different I, so it might be different. It might cause some minor effects on your calculation of the kinetic energy.
The I is 2.3. We have calculated the I is 2.3.
Okay, so the I doesn't change when you.
Doesn't change.
Okay,
Because
so
we use the same spaghetti.
but but I mean when like because you have different breaking when you break there are.
Yes, it's not changing.
Oh, so it doesn't
Yes,
change. So
it's not
okay,
changing.
so I think it might have some factors, so maybe it can be $1. And can we talk about so the uniformity of the spaghetti? As you said, you use the same spaghetti, but can you ensure every section of it has the same density? Is that also possible?
We have to calculate the younger measure.
Yeah,
And
for those.
to calculate the every spaghetti about the I and the younger measure.
Okay, then what about, how do you measure your deflection? Because can you show the one?
I didn't say the diffraction is set. I said the diffraction is didn't set because I have calculated the elastic potential energy and elastic potential energy is different. But because the mass also, when the elastic potential energy increase, the mass also will increase. So it can that.
Okay, so can you please send to the one to explain your theory? Maybe 10, 20, and a little bit more. Oh yeah, here, the former page. Yeah. So and here, so I see the energy transformation equation there. Do you consider there will be some possible like an environmental drag force, like this air drag force or like friction with the sea?
Yes, it can affect by the friction or another, but I also sure about velocity check.
But you didn't put it in
Yes,
your theory?
yes, we didn't do that.
So there might be some deviation between your theory and your real experimental data.
Because the friction is very difficult to calculate, but we have to explain about friction.
What about do you have the data of your distribution of your spaghetti? Because is your spaghetti goes at the same position when it's into it all goes to when injected?
No.
Does it all goes to the same point? Like does it,
All goes for about distance.
yeah, does it drops at the same spot? Like when it's ejected, does it goes at a certain point? Like
We only calculate about its velocity, no calculate about
so you didn't try to keep a record of the drop in spot?
Yeah, because private statement only says the pricing has speed, so I only
Oh yeah,
calculate
okay.
about
So maybe
speed.
in my opinion, I think you can through this observing the distribution of the spaghetti rotation, you can prove that if your force applying is correct. So if there are slightly different collisions, you could bring about the different landing positions.
I have calculated the price force, and I see that the spaghetti ejection distance is not very important because I arrived to calculate the price force.
Oh, right. And can you show the point that is about the function?
Diffraction?
Yeah, in your
Data?
no, I mean the theory part.
Okay.
So does your eye changes when you're spaghetti? I mean, it's when you use different radius of your different diameter of your tube. I see.
Yes.
I heard you say that your lens of spaghetti will be slightly different.
Yes.
And in this equation, I believe that this will cause a slight difference because the view will change. Do you agree on that? Because I mean, there will be slow, like is there a lens controlled, like every lens of ejection is that a controlled lens? Like
You say calculate the length is calculate the ejection length?
yeah, are they all the same?
Yes, it's very simple because we have to use the arrow bar, but arrow bar is very small, so it's very simple.
Alright, so can we maybe talk about how this so you change the diameter, so how do you think that is corresponding to your theory, like the lengths are differences?
You said about length increase. The length increase because when the diameter increase, the at the lag angle, so this curvature also will decrease.
Alright.
So the length will increase.
Yeah, so also in that diagram, when you have bigger Ellis diameters, the spaghetti will be longer. Is that, am I right?
Yes.
The down graph.
When the diameter increase, the length will increase.
Okay, alright. And so does that correspond to your theory? Like, can we get a exact value from the theory? Do you have any theoretical data comparing to your experience?
Compare to experiment because I think this can use to see that because the diameter increase the length spaghetti at that angle, so this curvature will decrease.
And yeah, so
Yes.
so does it
So length will increase.
yeah, does it have like do you have the value in your
Value.
I mean in your theory does changing this length will affect like
Okay. Well, the length will affect the mass, and the mass is in the this formula is about mass.
and okay so can we okay so about that omega like the angular velocity can I ask about how you measure it? Like you said it like it is a constant it's a controlled value, like it's all the same angular velocity at different under different conditions. So the angular velocity are all the same. Am I right?
Yes.
And so how do you calculate the angular velocity?
We use this is a spaghetti have draw a point on spaghetti and to calculate the spaghetti's rotation. Because spaghetti rotation is this rotation at least. So we have calculated draw a point.
Or so your rotation is going like on this.
Yes.
Alright, so let's see. So when at bigger radius, the velocity will affect whether, so the bigger the curvature is and the bigger the velocity is that right? Where the curvature is bigger and the velocity is bigger.
Yes.
Okay. And then the diameter bigger and the velocity bigger.
The diameter increase, but the velocity will decrease.
Due to the mass increase.
When the diameter increase, the spaghetti curvature will decrease, so the velocity will decrease at least.
Sorry,
Thank you.
please summarize your.
Okay, so basically we talked about how the I in this in their theory does not affect their terminal, and we also talked about the direct force and where they didn't put it in their theory. So I believe that the force should also be considered when calculating the total energy of the system. And also we talked about the angular velocity and how they measure it. So and it stated that under different conditions, angular velocity will be all the same. But in my opinion, I think there will be a slightly change in angular velocity. And also about their about the collision before it existed. And so they're saying that they do have the collision, but they say collision wouldn't affect their velocity or will not cause the engine loss. But in my opinion, I think the collision before existing will do something to total energy. Okay, thank you.
Questions from the viewer?
And now I'm gonna ask the reporters, how's the sensor works in your experiments? The sensor. You put spaghetti in the tube.
3D printer.
No, I said the sensor the machine. You put a spaghetti in the tube.
Yes.
And the tube is 3D printed.
Yeah, 3D printer.
And how's your sensor work? Can you turn to your page that is experiment out?
Yes.
Yes. How is it work?
Control is
Yes.
we have light into a 3D printer, and the 3D printer can change the velocity and control velocity.
Okay. And now please turn to page 7. And what's the value of it?
It's about stress, and but because it have the tube, so it's not break.
Okay. And now you do the experiment about the diameters of the tube.
Yes.
Yes. And first the experiment data.
Experiment data.
Yes. Of the diameters.
And the tube diameter change
Yes. The parameter.
in here.
And what do you think about the diameters? How will affect how it affects the spaghetti's velocity?
Also, I think with bigger diameter of the tube, the total length of the ejecting spaghetti might be bigger. So those will cause so the bigger the mass is, it might have the smaller velocity, like with bigger mass, and with the same, and say they apply the same force. But when with the bigger mass, I think the velocity will decrease.
And did you mention about data in the page 7? Page 7. Did you mention about what's this?
I didn't because I'm not really sure what this is. Is that just is that a stress?
Stress, yes.
So is that the value of stress?
Yes.
Okay.
Okay, I know. And this is all my questions to useful. Thank you.
Thank you. please give your review.
Okay, hi, I'm John from Team Music, and today I'm gonna review the discussion of the reporter and opponent. And here is the problem statement. And we got many will talk about the high speed of the spaghetti when it out of tube and the parameters of it. And the next page. The reporter, I think she has a clear mind to ask an opponent. And he has the conclusion of the person and let us know about what's these problems and what we're gonna talk about what we're gonna talk in the report. And the second one, she used the force sensor to control the force to make sure the force in every experience is the same and reduce the the mistake that makes by human. And he has the graphic to experience her theory. Great, and so let us to know the theory faster. But his lack of the experience video and the picture, because we need a picture and a video to understand the experience faster. And you can use trackers videos to let us know where the spaghetti goes and the spaghetti's velocity. And she's parameters isn't very well because the diameters. I think she didn't mention about the place that he touched is the same. And I suggest her that she can add more video of the experience, and he can explain the numbers like page 7's number to let us know what the number is. And the next we gotta talk about opponents, and he has a clear mind to ask the reporters questions, and he understands the report very well, so he can ask the great questions to the reporter. But he spends too much time on the single questions, so it will waste too many times to discuss with the reporter. And I think he didn't have to spend too much time on asking questions, so he can ask more questions about the parameters or the value of the data in the experience video or the picture or the experience setup and the machine, so that we can know the questions very well. And here's all my reviewing.
Yeah, the judge, please give your concluding remarks.
First, about the set out the review asked me about the set. Review said we control the force field, but we control is the velocity, and we force sensor only to make sure the every experiment the force will send in a one variable different curvature the force can change. And about the diameter, when the two diameter increase, the spaghetti curvature will decrease and the mass will increase, so the velocity will decrease. And about the opponent asked me about the friction and the normal force. I see that here the normal force is vertical with the spaghetti, so that affect more, and the friction can more. But I have shown about the velocity change, and the opponent said I need to calculate about distance, but I write to use this formula to discuss about applied force. So I see either to calculate about distance, and I think this power statement is important. Supply is the high speed. So I think the velocity is very important in the break region, and the velocity is important. So I think very important is about velocity affect elastic potential affect spaghetti, and spaghetti mass decrease, so elastic potential will affect more to the spaghetti. And the opponent asked me that about spaghetti's diameter will change, but in every experiment, spaghetti diameter is same and break also is same. Thank you.
Okay, thank you very much for your discussions. So, now there will be some questions from the
So, question for what is the big question of this question, and what is your main conclusion? And the opponent says that collision and jet force is important. Why? Why do you think of it is important? And how do you think of this? A big question and the main conclusion of your statement. If you want to use one sentence to conclude it, what would you say? Use one sentence to conclude. This is maybe your major conclusion. What is the big question you want to answer?
The pricing velocity. Pricing has velocity as is very important.
And why the jet force equation is important? Why do you think it is important?
Because I saw her calculating the energy, and I think that will be some of the factor because you only put on the energy of the spaghetti and also the rotation energy, so I think there will be more energy causes to that, and also the collision. Well, the collision will also cause the difference in energy too.
So is there any okay, so and how do you think of these two?
These two questions, I think, can you please again?
What is the big question of this limit equation, or what is the major conclusion?
The major conclusion is, big question is the total knowledge experience very well with us.
Okay. So, okay, thank you.
I have a question about the angular velocity. The pointer show that point out that the points are the center of rotation. When you draw your point, there are several points. What's that? Those points.
Those point is about we draw the back point and the spaghetti and see the point can rotation and to calculate the angular velocity.
So, what's the center of the rotation? Where is the center?
Need this.
Yeah, where is the? Because you have an omega, right? So omega must be the velocity.
And this that yes. This can match.
So if you have spaghetti, then it's this kind of rotation.
Because the spaghetti have two and here is fixed, and when we push the spaghetti is not pass through the center mass of center, so can have a like this. And so when the spaghetti break, can have the angular velocity like this.
Do you observe this kind of rotation? Do you see this kind of rotation?
Yes, I see, and I calculate the velocity.
Okay, what do you two think about that?
First of all, I think she said that all her angular velocity are all the same throughout under different conditions. I think I have a doubt on it, and also I think she didn't make it really clear what kind of rotation it is. Because first of all she said it's like this, is it like this one, and it's slightly because it didn't really make it clear like what's the real kind of the rotation, and I think that will affect the calculation of the energy.
I think her function of the rotation isn't very well, so I can totally understand what she's talking about the twist.
If there's no more question, then let's mark scores. Please. Okay, then let's have the scores. For the scores for the reporter are 6, 6, 7, 6, 8. And the scores for the opponent are 6, 6, 8, 6, 7. And finally, the scores for the reviewer are 6, 4, 8, 5, 6. The any jury also have something come out? Okay, if not, then let's take a short break, about 10 minutes. 10 or 15 minutes. Okay. Thank you.